Everybody else thinks it's spring break already.
It should be.
It should be spring break already, yes, I know.
Any questions before we pick up where we left off?
Why isn't it spring break yet already?
Well, at least they didn't do spring break Tuesday through Thursday. Done a couple times.
That's
Like a normal school, yeah.
Why don't they just do it Monday through Friday? You don't know.
Yeah, I am not part of the calendar committee.
I was just joking when I asked that question anyway, like.
Yeah, I can just imagine the headaches they're going through,
Yeah.
trying to get everything balanced. And at some point, they just go, you know what, that's good enough.
How did we do on the tests?
Okay,
Okay.
it's always that as a grading the tests, at this point, they're marked right and wrong, I haven't come up with a final grade yet. As I grade them, there's always that hope of, this is the group that's gonna catch it all. Just, only Carol Sanders.
Probably never is.
I just set myself up for disappointment.
I completely, forgot about potential, that was my big thing. Or like, what happens with potential inside of a sphere, or inside of a solid sphere? Figure out that it's the surface that you count, because it's constant inside the sphere.
Yeah.
Totally just blanked on that.
Zero.
No, it's not zero, it's constant,
Constant.
because it's based on the surface then.
Yeah.
The electric field is zero, but.
Yeah.
I think I made it 20 volts. Is that the way I had it set up to class?
I didn't write that one down.
Okay. Well, if no one wrote it down, then we'll assume that I nailed it.
Okay. You just picking right where you left off?
Yeah, unless there are questions.
Yeah.
I thought I wrote it down, but I guess not.
Well, sometimes the boards leak after images.
There we go, another one.
And then number 4. All right, so the question is, what is the current flowing across the resistor? There are a couple techniques to do this. We're going to do the equivalent resistance technique. And then on a different diagram, we'll show you another technique that we could use. All right, so let's find the equivalent resistance. We go piece by piece. So are there any resistors that are in series or any resistors in parallel?
There's one in parallel at the top.
Okay. I do want to point out that we assume that the wires have no friction in them. Any friction in the wires is sort of captured in something else. But this right here is just one giant junction. 1 and 2 are indeed in parallel. So for resistors in parallel, we have 1 over 1 plus 1 over 2 is 1 over my equivalent resistance, which is 3 halves. And therefore my equivalent resistance is 2/3 of an ohm. So I've taken this and I've now reduced it to the 6, 4, 5, 2/3 of an ohm, this is 3 ohms. But 20, not 12. Right. Again, we look, are there any that are in series or parallel?
Well, it's hard for me to decide because they're like on corners meeting each other. So I guess because it splits off and then goes one after another, right?
So which,
Like 4 and 3. Well, wait, we're going from the top.
yeah, current's
So I
gonna be
guess
flowing
three and-
this way.
Okay, so they're gonna go to the parallel one and it's going to go down at the same time?
Yeah, it will split. All right, so typically on something like this, if you get the first one correctly, that it's in parallel, we're probably gonna be flipping back and forth between parallel and series. So is there any resistor that a current's gonna run through that it will have to run through, the same amount of current have to run through another resistor?
Okay, the 6 of, and the parallel ones, right?
6 and the parallel ones, with this and that?
Yeah.
Well, the current's gonna split between the two. Whatever's flowing across one doesn't have to flow across the other. And by the way, for those who came in, after I announced that my wife has COVID, if you were interested in wearing a mask, I brought masks.
That's a tough decision.
It's up to you. The last class, all but one wore a mask, and this one was like, no one's really opting for the mask.
If you would've said you had COVID, that would be a different story.
I would be happy now.
Yeah. Like, and you might, but we don't.
Yeah.
Like the fact that it's like up in the air is like less of a concern to me right now. Or roll the
Well-
dice, a little more likely to roll the dice, I guess.
It's a question, did I give my wife COVID, or is she about to give me COVID?
But you don't
Their
feel
mask
symptomatic.
gets you like to wear when my wife has COVID. And I'm around other people more than she is. So odds are that I'm over it. And she's just becoming dirty, or this next week's gonna suck.
Did you feel like you were sick over the weekend?
No,
No.
no, it still seems to be asymptomatic.
Or you just didn't get it in the first place?
Yeah, I'm about to.
And she,
When? She started feeling sick on Saturday. All right, so current's flowing in, hits the junction. It's gonna split. Anything that flows across the 2/3 has to flow across the 3. Because any current flowing this way, there's no other choice but to go across that. These are in series. Anything else we can't really identify, because I have a junction here, here, and here, and they don't have any two resistors where they have the same beginning and end. Once I combine these, then we'll have it. But these two are resistors in series, and you just add them. So we've now taken this to that's the 4 ohms. This is 3 2/3, so 11/3. So we've now simplified it to that. And once again, do we have any that are in series or parallel? The answer is yes.
I guess the 4 and the 5 are in parallel then?
They are not, because they don't have the same beginning and end, because I got the 6 ohm sort of interfering with that.
11 or 3 and 4 be
Yeah,
in parallel.
have a junction here and a junction here. They have the same beginning and end. So I'm gonna call this R1, 2, 3, and R4, R5, R6. So, 1 over the combined resistance of 1, 2, 3, 4 is 1 over 4 plus 3 over 11, which is 14/44. And so my equivalent resistance is 44/14 or 22/7.
So their same beginning is that top left corner of that right box then?
The top here.
Yeah, that, is that the same beginning you're talking
Yeah, well,
about?
all of this is basically a junction, because there's no resistance in between them.
Okay.
So are we trying to find like the simplest way to add them all together?
Oh.
What I noticed that from that image, you add those parallels first, and then from that one you added the series, and then from that one you added the parallels that are just very simple, doesn't have a lot of like resistors.
Started fading off there at the end.
Oh, sorry.
We are trying to, we're trying to figure out what is the current flowing across each resistor.
But you're doing it like step by step.
Yeah.
Like the easiest one, because the easiest one there is obviously the tiny one right there. And the easiest one right there is the series right there, and then that one is
Yeah,
parallel.
and then we'll keep, and typically, you'll flip back and forth between series and parallel, series and parallel. If it's possible. We will get to ones where you can't do that. So there are multiple techniques of doing this. I'm just doing it. I'm gonna find the equivalent resistance. We'll figure out the current flowing out of the power supply, and then we'll work our way backwards. All right, so these two are in parallel. That should be the equivalent resistance. And so I've now reduced it down to the power supply, coming up here. All of this is one thing. Of 22/7 ohms. That's my resistance of 1, 2, 3, 4. And then, let's see. That's 6 ohms, 5 ohms, that one. All right, now it's looking sort of bizarre. The question that comes up is you're reducing it, how do you know what you're substituting in? Well, if I think about this as in parallel, the left side of it, the left junction, is connected to the 6. The right junction is connected to the 5. So my left junction, now top junction, since I rotated it, is connected to the 6, the other one's connected to the 5. I guess I could have drawn it less bizarrely. Okay, not that much less. So the left side's connected to the 6, the right side's connected to the 5.
So,
Would it be series?
Yes, because anything flowing across this has to flow across that. In terms of the original, we have current flowing in, it's gonna start splitting. Some of the current's gonna go across the 6, the rest of it's gonna go across this structure, which will meet up again, and then go across 5. So whatever goes across this structure has to go across the 5. So series, just add. So we've now reduced this to,
Could we add all of them together since they're all series? Or would it be just the 22/7 plus 5?
just those two.
Okay.
Because whatever flows across that has to flow across that, so those two are in series, whereas there's a junction to keep those from being in series. So we have our 6 here, and the other one is the sum of 5 and 22/7, so that's 35 and 22, 57/7. This is R 1, 2, 3, 4, 5. And then the last step, as we just whispered, parallel. So my total equivalent resistance, 1 over that is 7/57ths plus 1/6, which is something. Oh, there's a small one. What is it? 1138?
11 over 38.
Okay.
And then if you flip that, it's 38.
All right. Now, if I were doing this with a calculator in front of me, I would have probably done decimals for most of this stuff instead of fractions.
Oh, well, the decimal for 38 over 11 is 3.45.
All right, I will say, doing decimals, you need to go to at least 4 decimal places.
Okay.
Because any rounding issues we have here will get propagated throughout, and we'll end up with something that just doesn't look right at the end. So what did you get?
3.4545.
It's 4 or 5 repeating? Okay. Oh. 3 goes into that, 3 goes into that, 3 goes into. Okay. This is 20 volts. All right, so we found the equivalent resistance. Any questions up to here? Then let's start working our way back, could find the currents. So from here, we can figure out the current flowing out of the power supply. What is the current? How would you find the current flowing out of the power supply?
Would we use Ohm's law?
You bet we would. Because if I gain 20 volts here, I'm going to lose 20 volts going there. So if I use Ohm's law, I get 20 is equal to I times 38/11ths, or 3.454545, etc. And we end up with a current coming out of the power supply of
5.799.
5.789.
94. No, like 5, sorry.
5.
It's also.
5. Okay, you said it's also what?
Repeating.
Oh. No, I don't think so.
I don't know.
It didn't look like it when I was thinking.
Oh.
Anyway, all right, units?
Amps.
Yep. All right, so that is the current flowing out of the power supply. 5.7895. So 5.7. And now we're going to sort of start working our way in the reverse direction. So I can now find the current flowing across the 6 ohm resistor. By Kirchhoff's voltage rule, I start here and go around any circuit, and I end up back where I start. I should have equal gains and losses. Well, Same is true for the 6. So if I gain 20 going across this, I have to lose 20 going across the 6. So I can now find the current flowing out of here. Again, Ohm's law. I have 20 is equal to 6I. 3.33. So I now know the current flowing across the 6th node. So if I've got 5.7895 amperes flowing up here into this junction, and I know I have 3.3 repeating amperes flowing down, what has to be flowing down this side? Or how would you find it? Yeah, because the junction rule is that whatever current flows in has to flow out. So if I have 5.8 flowing in, 3.3 going this way, whatever's left over has to be going down that path. Making sure at least 4 decimal places. Well, that's the current that flows across this structure here, this whole structure here, and across the 5. So we now know the current flowing across the 5. Or looking at this junction right here, I have 3.3333 flowing in. I have 5.7895 flowing out. This has to be the difference. Flowing in. 2.4562.